Welcome back to Mullet and the Whale, everybody. This is our second video, Teach Mullet How to Code, because he currently does not know how. And we're going to start out with some very, very basic examples. Just a little bit of housekeeping at the moment. We're going to set up a new project. This is just going to be for demonstration. If everything looks confusing and cryptic here to you, Zach.
Yes.
Good. Most of it looks cryptic to me.
Okay.
One thing I will say is that as you learn more and more stuff, you kind of get a sense that you'll never know everything.
Okay.
But one of the most basic things you can create is a console app. Don't get excited. It's not an Xbox or a 360 thing. We'll use .NET Core. I think that gives us everything we need.
So what's .NET Core?
I'm glad you asked. Give me a second. I will bring it up and we'll have a chat about it.
Okay, that's
I'm going to make a new folder for our projects. We're going to give it a better name. Seed planting. I know you're a fan of this method of teaching. Name things well at all times.
Name what?
Name things well, as in everything. Or at least try to.
Name as in from what context?
Of all contexts related. In this...
Okay.
Yeah, in this domain...
Okay.
Anything that you can give a name, you want to try and give it a meaningful name.
Okay, that makes sense. I now understand what you're saying.
Yeah. Okay.
So what you're saying really is you want to highlight even the little stuff so that you know what it means.
No.
No? So
No.
what I'm thinking is like it's like a process and each part of the process should have a different name. Is that incorrect?
That's also... It's not necessarily incorrect, but that's not what I'm saying.
Okay.
It's... Give things names that represent what they are.
Okay, so there's a psychological theory called chunking that breaks down a lot of information into like one phrase, but when somebody repeats that word to you, it actually signifies all the other information. So that's essentially what we're doing. We're chunking the information into one relevant thing.
I'll get back onto that. That's a very interesting thing to say. At risk of going off on a massive, massive tangent.
Yeah.
That's basically kind of the right idea.
Okay.
But really, it's call things by a descriptive enough name so that you're able to tell what they do and what they are for. It's when you come to something 6 weeks down the line, and
you know where it is.
Yeah, and we're getting off track. I mean, that was just to be a seed. Okay. We have our Solution Explorer over on the right. This is everything that's in our project. We have one file, which is program.cs.
Yeah. Okay.
Do you know what the letters CS stand for?
Coding software.
Nice try. They stand for C#. So the C actually means C. And then the S is sharp. So this is a C# file, which means it contains C# code.
Is that so? What does C# stand for? Like, does it represent?
It's just the name of the language.
Okay, so C# is like a language. So it could almost say English, and then when we do something different, it could say French. And if we did something different, it'd be in Spanish. So it's like C# signifies the language that's being used.
Yes, C# is the language that's being used.
Okay, that was good. I was going to sing for you in C#. Huh? I'd be like, no, I'm not going to sing. But yeah, okay, that makes sense.
I'm almost convinced that's not C#.
Yeah.
Okay, so C# is a language. Now, you just mentioned some other languages. French, English, Spanish, Welsh. What do you think the main difference between a language like those in a language like C# is. You can see some C# at the moment. 13 lines of it.
I don't know, they involve numbers?
Well, what's a language for? Okay, so C# is a language that a computer is able to understand.
Yeah.
It does involve numbers, but that's too basic. It allows you to communicate logical ideas of things that should happen to a computer.
Okay.
And kind of in a way that we can understand as well.
Yeah.
So, with any computer language, there are rules.
Okay.
Like there are rules with any language, it's called syntax. The rules of the language is called syntax.
Okay.
But unlike most languages, with a computer language, if you break the rules, you don't get anything. Okay, so basically, you have a piece of software called a compiler, which takes this stuff, which is just text, just regular text, and converts it into something called IL, which is intermediate language, which is much less human readable, but much more easier for a computer
IL
to read.
stands for intermediate language.
Yeah, it's not really relevant or important. I'm just describing the process.
That's
you'll
cool.
probably never see
it. I'm understanding. So what you're saying is there's a language that's spoken, and once it's like formatted in a certain way, it creates this other thing that is.
No, it only if it's formatted correctly within the rules of the language, i.e., correct syntax. Then it can be compiled. Which is basically, think of that as the process of turning your code into an actual program that you can run.
Okay, that's cool. That makes sense.
But if you're, like if I do this, oh my god, Visual Studio so slow. Instantly before I even try to compile it, it's going, no, I'm not going to do that for you. Sorry, I don't know. I don't know what this means.
So the way that I'm understanding it is, if you imagine a light bulb, to make that light bulb go from off to on, you have to press a switch, and all these little the C# code is almost like the wires and the electricity leading to the light bulb, which is the end product, like the program that we're trying to create. But everything has to be in place for the light bulb to be able to be turned on.
That's kind of an odd analogy. It's more like a set of blueprints for a tool.
Okay, so like putting like a drill together the correct way so that it functions.
Yeah, you can't build the drill if you have incorrect blueprints, and the person who would build the drill would be the compiler.
Okay, that makes sense. Yeah, that's cool.
Okay, now in reality, and for practicals and keeping things simple, we're going to bring things way back down to earth now. But I want you to kind of remember that idea. The text is not what gets run. This is just our way of describing what we want to happen to the computer.
Yes, this is just our language.
Translates into IL, and the IL can be run on the, and that's run by the .NET framework.
Okay.
You asked before what .NET was.
Yeah.
.NET's able to take the IL and execute it, as in execute means to run it. So.
Okay.
Yeah, and we'll go into that in more detail later on.
Okay.
For now, how complicated does this look to you?
Relatively complicated.
That's okay. Let's just say, for example, it all needs to be here.
Yeah.
Technically, the namespace doesn't need to be there. The only thing that's relevant is this bit.
Okay.
More specifically, anything within these two braces. You notice how the different parts of the source code are divided up into, they look like blocks. They're called scopes.
It reminds me of Excel, to be honest, when you click on like a line at the end.
What?
Do you know, like when you've got Microsoft Excel and you've got like a graph, but if you click on one side of the graph, you just get a line that goes across?
I don't think I've ever seen that. I do like
Okay.
Microsoft Excel though. You'll actually find lots of parallels in Microsoft Excel to what we're doing. Imagine this as Excel on like super steroids.
Yeah.
It's way more than that, but that's a good way to think about it. So when it's run, everything that's in the block that's called main.
Okay.
Oh, I will say one thing. Everything that's in blue here. Not that. That's a slightly different shade of blue, and it might be different on your IDE.
Okay.
Like whatever software you're using.
Yeah, so here it says static and void in like a dark blue, string in a dark blue, and then ARGS is in like a slightly lighter blue.
Yeah, because that's something different. Okay,
Okay.
but they're all different. But the ones that are in dark blue are reserved words.
Okay.
By the C# language. That means you're not allowed to call things that. They have a specific meaning in the C# language.
Okay.
Okay, main kind of does. Main's a weird one. But basically anything that's inside of main.
Okay.
This is what's going to happen when we execute our program. It's going to go line by line, one after the other, and do it. Now, I was going to show you the classic. There's a classic demonstration for when learning a new language or teaching developers.
Okay.
And it's called the Hello World, and you write a program which displays the words Hello World on the screen. Unfortunately, when you open and start a new project in C#, that's exactly what it gives you, as you can see.
Okay, yeah, that makes sense.
So, we have this 3 different types of things that can go in here.
Okay.
Well, actually, let's not get ahead of ourselves. Shall we run this and see if it works?
Yeah, go on.
We'll go up here to the build menu. Control Shift B. That's the shortcut for build. Build started. Once succeeded. 0 failed, 0 save, 0 skips. It succeeded because we've obeyed the rules of the language.
Okay.
And we can run it. Start debugging. F5 basically. And you can see that. This is the console, by the way. This is why this is a console app, because it runs in this console. Hello World, and then that's the end of the app.
Okay, so what we do is, what I want to know is, how is this relevant to the big picture? So where it said Hello World, when we're saying we're doing like a word-based game, is this where you kind of put the text for the game?
What, in the console?
Yeah.
Maybe. Maybe not.
Okay.
Where it actually ends up isn't too important if you design your software right.
Okay. I assume that comes at a later date.
Yeah. But try and just keep focus on how to utilize the things that I'm talking about.
Okay,
like
so
right
if
now.
where it says Hello World,
Yeah.
if you changed Hello World to different letters, would that just come up on the next screen when you press debug?
Well.
So if you change that to Mullet&TheWhale.
Like that.
Yeah.
Yeah. Shall we try it? We'll just press F5. If it's not build, as in if it's changed. Yeah, okay. So now we've changed our program. It's still correct.
Okay.
What if I was to do that?
What did you do? Take away one of like the speech marks?
I took away one of the speech marks.
I
right.
I assume that won't work now. I assume the speech marks work as almost a start and an end.
Yeah. What they actually do is they define a string literal.
Okay.
A string is a sequence of characters.
Yeah.
WHALE, so on. So that's a string literal. Okay. We can also do more than one.
Okay, so if you do more than one, do you just come after each other?
Yeah. Because as I said before, it's not that they come after each other, it's they happen after each other.
Yeah, that's cool.
It's one happens, then the second one happens.
Yeah. You spelt 6 wrong, by the way.
Do apologise. Okay. The bit at the start, there's an object called console. We'll get into objects later, and we can call the command WriteLine on that object.
Okay, so going back to what you said before, we can't change the word console, but if you put console dot WriteLine like you just said, or you've just typed, we can then insert something after it, and that becomes a program. Is that correct?
No, the whole thing's a program.
So what do we call that? What are we calling this bit now?
This bit?
What? No, the bit that actually goes inside the speech marks.
Oh, that's a string. It's a string.
Okay, and the string is just.
Yeah.
Just like.
What's more important is these here. It's not what's inside the speech marks. It's what's inside this.
Okay.
Okay, so this is called a method.
Right.
WriteLine is called a method. We're trying to. Basically, it's a command that we can call. It belongs to console. We can call it. The bit after it, the parentheses, allows us to pass to it things as like the data that we want it to work with. It allows us. So, in this case, it's the string "Hello World." So we're saying we'll call WriteLine, and we'll give it the parameter "Hello World." Technically, this is called an argument, but we'll give it the argument "Hello World." So it's like, oh,
I'm just gonna have a sip of water. Sorry.
That's okay.
Yeah, carry
on. We'll say this before we go any further. See this little guy?
Yeah.
All statements and expressions have to be ended with a semicolon.
Okay, that's cool.
It'll tell you if you don't do it. Get used to it. It's hard to describe what needs it and what doesn't. You kind of learn by intuition. This is a statement.
Okay.
The difference between a statement and an expression is a statement cannot be resolved into a single value. It doesn't provide a value.
Okay.
An expression provides a single value when it's finished.
And how are these values relevant to the end process? Like, what do these values give you?
It's basically... no, go away. Okay. Let's... Now, the thing that goes inside these rounded brackets here has to be an expression.
Okay.
Because it has to be a value that WriteLine can use. So that has to be resolved before WriteLine gets called.
Okay.
Let's try this. What do you think we're going to see now?
8.
Why not 4 plus 4?
Because it's created a value. So 4 and 4 is a value of 8.
Well, it doesn't create the value. It's okay. So
it's the sum of.
The program gets to here, and it goes 4 plus 4. Oh, that's an expression. We need to resolve that. So it resolves that, and so it's the 8 that goes in.
Yeah.
Okay. Let's check this out. Whenever you see a single equals, that means a sign.
Okay.
It means the thing on the right goes into the thing on the left.
Okay, so they work together.
No. Let me just finish the example.
Okay.
What do you think we're going to see now?
Okay, so if I've understood this correctly, then you wrote Zach's name equals Zach. So now that where you've put right line in bracket, you've put Zach's name that represents Zach. So what we're going to see is Zach.
Let's have a look. That's right. What if
Oh, that's quite cool. I definitely learned something there.
What if we were to do that? Now what do we get?
Zach's name, because you put it in brackets.
Not brackets.
Speech marks.
Okay, yes, yeah, so that's a string literal, as in it's literally what's inside.
Okay, so
this is also a string literal, and a string literal is also an expression. The thing it resolves to is just that. It's just a string that's that. And we put this in here.
Yeah.
Okay. This is called a variable. It's for storing some kind of data.
Yeah.
We've told it what kind of data it has to be.
Yeah.
At the start, this is the rules of the language. If we was to do this, it's not going to be very happy. Now, int means a whole number.
Okay.
But not like this. Can't do that.
So I didn't really understand that. Can you do that again, please?
Okay. Which bit? Should we go back to this?
Yeah, so I understand this bit. Okay.
Why does that work?
Because when you click F5, it is going to come up with a 3 because it says string and then Zach's name equal. And so basically what that represents is what's in the bracket is Zach's name. Next to the string is Zach's name, and Zach's name equals 3. So whatever you put in this bracket...
Zach's name doesn't equal 3. Zach's name equals...
the
right in 3.
Yeah, sorry, that's what I meant. Yeah, so whatever... Yeah. Zach's name equals whatever's between these two red speech marks.
Okay. It doesn't represent it. Is it?
Is it? Yeah.
Okay. Now, so a string is a type, a data type. It means a sequence of characters. So...
Okay.
So we're allowed to do this.
Okay. When would we not be allowed to do this?
If it wasn't a string, or if one of these wasn't a string, or basically if that wasn't a string, or this didn't say string.
Okay.
It would be a type mismatch. You can only put a type in a container that's designed to fit that type.
Okay.
Okay, so there is another type which is very important, and that is the int type.
Okay, so we've got one type that's string and another type that's int.
Yeah.
Okay.
Int is a whole number.
So what string? String isn't a whole number?
No, string's a sequence of characters.
Okay, so...
We know it's not a whole number because we're putting in the word 3.
Okay, so right now I'm understanding.
The word 3 isn't a whole number. This could be
anything. So if you want a whole number, you have to put int. If you want letters, you have to put Zach's string.
Yeah.
Okay, that's cool.
See, this word. See, there's no way you could ever think of that as a whole number.
Yes, I understand.
Okay. Why is it not happy with me? Do you have any idea? You can see where the problem is because it has the squiggly lines.
Yeah. I'm not sure. He said it's a whole number, so.
But what is this?
It's just a number. It's the number 4, but you put it in brackets. So does that make it?
It's not in brackets. It's in quotes.
Quotes. Sorry, I keep saying brackets. My bad. Does it need to be in brackets? I'm not sure. You might have to explain this.
Okay, so anything that's in bracket, you got me doing it now. Anything that's in quotes is a string literal. This expression resolves to a string.
Yeah.
This isn't a string though. This is an int.
Oh, okay. So
we can't put a string, and it will tell us cannot implicitly convert type from string to int. It's trying to force a string into here, even though we've tried to trick it.
Yeah.
If we do that. Now it's the number 4. Logically, the number 4.
Okay, so you just don't put it in the
this is
speech mark.
The number 4 written down. It's hard to explain. Like, this doesn't really make sense. it might let you do it. Ah,
yeah.
Okay. So ignore the first line.
Yeah.
What we're going to see on the screen now?
8.
Are you sure?
No. You're gonna see just 2 4s because you've done it as a separate equation.
Well, it's not that it's a separate equation. I don't know if I'm explaining this the best way. These are strings.
Yeah.
Strings is just writing. That's the best way to think of it. It's some writing. It's not logically a 4. So you can do this.
Okay.
So
what's that going to bring up? Left 4.
Yeah, but the point is that this is exactly the same as what we just did before we changed it to a 4. To the computer, it's the same thing.
Okay.
The computer doesn't care what's in the string. It can't manipulate it the same way it can an int, because it knows an int is always going to be a whole number. With a string, it can't guarantee that we've not.
So the end product of an int always has to be a whole number.
Yeah, an int variable can only contain a whole number.
So why? Okay, that's cool. So the answer to an int, the end product will always be a whole number. Well, however, string can be manipulated.
An int, no, everything can be manipulated. Think about it as boxes, and certain shaped boxes can only hold certain shaped things.
Yeah.
A string has to go into a string shaped box. An int has to go into an int shaped box.
Okay.
But we can add ints together. So now if we do this. By the way, when I put those 2 green little lines in, it means...
I was going to ask that, but I...
Sorry, it's second nature to me. That means that line stops getting included. It's temporarily removed.
Okay, that's cool.
It's just ignored by the machine, not by us necessarily. You can also... It's the call of comments.
Okay.
Compiler.
Okay, that's cool. So,
yep.
I think we're at a good point in this first episode to do a small recap, then to summarize, and then to move on to better understand this stuff in the next episode. Would you agree?
I want to do one last example.
Okay, that's cool.
So what are we going to see displayed on the screen now?
10.
No, that's quite right. Because when we're dealing with ints, plus behaves differently. Rather than just jamming them together like it does with a string,
yeah,
it knows it can add them together logically. There's a way to do it.
Okay.
What if we do this? Now what do we say? I'm being unfair. Let me change it to this. And I'm going to change the thing that's displayed in here as well. Remember, these things are called variables. These are the boxes we put things in. Whatever's on the left gets resolved. Sorry, whatever's on the right gets resolved and moved over and into the one on the left.
Okay.
Same thing here to the one on the left.
Yeah.
Can you follow that logic?
Yeah, so the equal sign basically...
That's called the assignment operator.
Yeah, that is what then turns it into what came before it.
Well, it just takes whatever's on the right and puts it into what's on the left.
Yeah.
That's what it is. That's what it does. At that stage, it's an operation. It's not... It's like it's something that happens.
Yeah.
inside the computer. So what happens first? What happens on line 9?
5 add 5 equals 10. So
okay, so that gets resolved first.
Yeah.
Everything on the right has to be resolved first, so there's a single answer. That means this is an expression.
Okay.
Okay. Then what happens on line 10?
I'm really not sure.
Well, it's the same as line 9. This is an expression.
Okay.
So what's a sum? What do we know about a sum?
We know that it's in the line above.
Yeah. We know it's a variable. We know it stars an integer. That's what int is short for. Which is a whole number. And we know what integer it holds. Because we've just assigned it.
Oh, okay, cool. Okay, that makes sense.
Okay, so what's the value of this at this point? Remember, it goes line
10?
by line.
10?
10 is the right answer. Yes.
Okay.
So, what's the value of this? Oh, that star is multiplication, by the way.
Okay, so 50.
So this gets resolved to 50. Then what happens? The assignment operator does what? It takes whatever's on the right, puts it into whatever's on the left.
Okay, so into sum is 10. Okay. Into result is 50. So now if you put in something else equals result, then that result there represents 50.
Well, no, the result it does not that represents, it has the value of.
Sorry, yes. So I keep saying represent. So it becomes 50. Like a result now means 50 in terms of the language that we're talking.
It has a value of 50. Yes.
Yeah. Okay, that's cool. So I definitely think, like, I definitely 100% learned something there.
I would prove it. We get 50.
Yeah, and you can reuse that over. So rather than having to keep putting the equation in, you just put the word in.
Yes. We've calculated something here.
Yeah. So if you did result int new word and then result.
Here is a reserved word, by the way.
Okay. And then so equals result plus sum, then we are going to get 60.
Well, new word will have the value of 60, but we'll still see 50. Why do we still see 50? Have a look at line 13.
Console, right? I'm not sure. Why are we seeing 50?
What are we displaying? This is the bit that does the displaying. What are we telling it to display?
Result?
Well, what's result?
50.
Yeah, so that's why we're seeing 50.
Okay, so new word now takes the value of 60. So if we remove result and put new word in, then 60 is going to come up. Oh, okay, so that's cool. So like, I've definitely 100% learned something there. 100%. I know it's took you a while to explain.
No, it's okay. It's okay. You're doing well. Whoops. So,
how's this relevant to the end process?
This is one of the most vital things. Keep your eye off the goal.
Okay.
Focus on it a little bit. This is absolutely vital. This is the trenches, basically. Oh, by the way, we can assign. We can do this as well, just for a thing. So now we replace what's in new word. We overwrite it. That's very important to remember. When you assign something, you overwrite what's already there. So 60's there.
Okay.
So, but we resolve this first. So 60 times 10 is 600.
600. Yeah.
and then we put the 600 in. So the original 60 is gone, but we don't need it anymore. And it's 600. Okay. I don't really have anything for you to, other than to play about with this. There are other things you can do. These are, that's divide. You have plus. You have minus.
Times.
Multiply.
Do we have squared?
Well, there isn't an operator for that, but that squares it. So what's 60 times 60?
Yeah.
Now this is interesting. This is, I don't really know off the top of my head what 60 times 60 is, but the computer can work it out really quickly.
60,000.
3,000.
Damn it! That is so cool.
I mean, of course, it's 3,600. That's how many seconds we are in an hour. So yeah, so there is a way to do squaring. You raise it to the second power. I think you can do. So you raise it to the second power, and then it doesn't like that. Oh, it's good. Try to use a double. Yeah. So there are a couple of other types of numbers as well. You have floats, which means it's a floating point value. Basically means a number with a decimal place.
Okay.
You have double. Now, these are types, so like string, int. A double is a higher precision one, and decimal is higher precision one again. And the most important one, which we'll talk about next time, bool.
I thought you were going to say boob then. That'd have been quite funny. What's bool? Oh, we'll talk about this next time.
Bool something equals true, or bool something equals false. Cannot be anything else. It can't be a string with false in. It can't be a number. It can be true, or it can be false. Okay.
I assume we're going to learn the relevance of that in the next episode.
Yeah, that's basically the core of all computing in history ever.
Okay, so we've kind of, I assume, reached the end of this.
Yeah.
Are you still there?
Yeah.
Give us a quick. Sorry, my microphone went off. Do you want to give us a quick rundown of what we've been through, just to recap?
We talked about what the C# language is, what it means to compile it, what it means to follow the syntax of a language.
Yeah.
Difference between expressions and statements.
Yeah.
A few basic data types.
Yeah.
How the program runs from top to bottom. And how variables can hold data.
Yeah.
Yeah. Now I have a question.
Yes.
Can you tell me off the top of your head what the difference between a statement and an expression is? Okay. So you can't. That's okay.
No, I think I can.
Okay.
So I think, like, the way I want to describe it is like a statement is a whole thing, where an expression is a combination of things that creates a whole thing.
You're not too far off.
That's how I'm seeing it in my head now. I don't, like I say, as we've said throughout the video, this is my first time doing this, so I don't expect that to be
that's okay.
Accurate.
What I was going to say, well, it's not right, but what I was going to say is find out, watch the video again, as if you can solidify the concepts. It's not really that important a concept. It is important, but
yeah.
It becomes part of your work without you really thinking about it too much.
Okay.
But I'll give you a clue. This bit here is a statement. These things are expressions.
So a statement's something that can't be changed?
No. Go on.
The expression creates the statement. Or adds value to the statement. So what I'm trying to say is, whatever an expression becomes, the statement is like the end product of the expressions.
No, you just said whatever the expression becomes. An expression resolves down into a single value.
Yeah.
A statement doesn't. What's the value with this? For example,
whatever you put into the brackets.
Well, No, because I can't do... I'll explain what var means next time.
Okay.
I can't do that. Cannot assign void to an implicitly typed variable. What that means is void means no return types. This doesn't... I can't take the result of this and put it in a variable. It just does something.
Okay.
It's a statement. It doesn't give me an answer or anything. It just displays something on the screen.
Okay, yeah. Wordy expressions can provide answers. Or
expressions provide something.
Yeah, we don't want to give it an actual form, but
See, the thing is this bit here, that's an expression.
Yeah.
And they're often mixed up. And
that's
in fact, only an expression can go here because it has to resolve this so it knows what to give to right line.
Okay, so the statement and the expression kind of work together.
Very much so.
Yeah. Partners in crime.
You'll find yourself doing a lot more expressions and statements probably, but
okay.
Yeah.
Okay, so I think that was super interesting. I think one thing that we might be able to do, because I bet people have got to the end of this video and who are watching it, and maybe we should, once the video is finished, put like a summary of what we've been through, like how we summarized it, but put it just at the front so people know what they're looking into. Because I feel like we've been a lot there, and I've learned a lot there.
I don't know, because to summarize it is to teach it
to
again.
be too vague. Yeah, too vague, isn't it? Maybe, okay.
We'll talk about that a bit later.
Yeah, cool. And if somebody has read this video and has an idea, then just drop us a suggestion, you know what I mean?
And if I've made any mistakes, I'm not sure if I have, but...
You probably haven't.
It's possible.
Yeah.
I mean, I know the program works. Okay. Yeah, have a play about with this. Try not to ask me any questions.
Between.
Yeah, if you do anything that's good for the video, I'll just defer it to the video.
Yeah,
I'll certainly write them down.
I won't ask you questions between the video, 100%. I'll save them for the video and then ask you during the video.
Okay, that's excellent. Thank you guys for watching.
Yeah, that was super,
see you next
super.
time.
See ya.